You are welcome to today's class. In today's class, we are trying to understand about Newton's third law. Okay, Newton's third law of motion. In today's class, we will try to understand about Newton's third law of motion. See, Newton's third law of motion. Everyone feels that this topic is very simple, but I can tell you with 100% guarantee that 90% of students they do not understand Newton's third law. 90% student, okay, they do not understand, they do not know about Newton's third law, though it's simple. See, everyone knows the statement that is, to every action there exists equal and opposite reaction. See, statement is very simple, but gist, it is very difficult. You do not know Newton third law. 90% students they do not know. Equal and opposite reaction. To every action there is equal and opposite reaction. They are able to tell this statement, but they do not know the Newton third law. There is misconception behind Newton third law that in today's class, go through this video till the end, everything will be clarified. Okay. Now see, to every action there is equal and opposite reaction. What does it mean? See, action, reaction. So there are two forces, action and reaction. Okay. Now this statement can also be written in another form. See, so that it will be much more clarified. See, if two objects interact, the force let us say F1 to exerted, here 1 and 2 means body 1 and body 2. Okay, the force exerted by object 1 on means first object and second object, that is object 2, is equal in magnitude and opposite in direction to the force F21 exerted by object 2 on object 1. Okay, so here if you see this F12 and F21, this F12, this 1 2, see, F12 is force exerted by object 1 and object 2, and F21 is force exerted by object 2 on object 1. See, I have given vector sign, so I need to write minus because direction is opposite. See, here in vector and scalar also many students have doubt. That is, see, I will try to clarify. F12 is equal to F21. It is correct. But if you put arrow, and if you write F12 is equal to F21, If you put vector sign, then this is wrong. Okay, because here direction is different. So if two objects interact, the force F12 exerted by object 1 on object 2 is equal in magnitude and opposite in direction to the force F21 exerted by object 2 on object 1. Now see, there are few points that you should remember. Okay, before applying the situation, there are few rules whether for a given two body you can apply Newton's third law or not while solving the problem. See, one case is this action reaction pair okay, this action reaction pair which are two forces exist together at the same time, same time. It is not action first and then reaction, it is same time. You can even say reaction first means reaction and then reaction action, you can say. See, what I mean is, see, seeing this action reaction, this word, you will get confused. Okay, action takes place and then reaction is taking place, but both this event is simultaneous, means it is happening at the same time. So action reaction pair exists at the same time. And one more thing is these two forces should be of same nature. Should be of same nature, means same force, same nature. Okay, here same nature means, see, same nature means I'll try to give one illustration. Means both, if one is gravitational and another is electromagnetic force, then these two forces are not same. But gravitational they are same, normal they are same, tension they are same. So these two forces should be of same nature. That is the another point. So you cannot take gravitational force and electromagnetic force as the action reaction pair, you cannot take. Okay, these two forces means action reaction force. Okay, these two forces of the same nature. Again, two forces means action reaction, two forces, action reaction, that is action reaction should be exerted on two different bodies, okay, not same body, two different bodies or two different objects. So this point you should remember. See, action reaction pair exists at the same time. It is not that action is happening and then reaction, it is, they both are simultaneous. Okay, they are occurring simultaneously, so they are happening at the same time. Two forces should be of same nature. Same nature means, see, one cannot be electromagnetic and other gravitational, both should be electromagnetic or both should be gravitational. So this is another condition. And third one is two forces, action reaction, should be exerted on two different bodies, not on the same bodies. So see, we'll try to understand by taking one illustration. See, I'll try to give one illustration. Let us say one block is there. Okay, illustration. Let us say one block is placed on the ground or table, you can say. Okay, let this be table or ground. Let this block mass be m. Now if you draw free body diagram, see, this block is static, it is not moving, it is at rest on the ground. Now this is free body diagram. So at first you should identify what are the forces acting on this body. See, one is due to gravitational force, weight of this block which is acting vertically downward, mg. And since this block is not moving, another force, there should be another force that is avoiding or that is preventing block to move, and that force is normal that exists here. Normal exists here. Okay, this is due to electromagnetic interaction between these two surfaces, means surface of the block and the surface of this table or ground. So this N normal is the electromagnetic force. Okay, now some student, what they will write, N is equal to mg. No doubt it is correct while solving the problem, but here for N equal to mg, if you say it is due to Newton's third law, it is due to Newton's third law. If you say it is due to Newton's third law, then you are 100% wrong. You are 100% wrong. You are not correct. Okay, you will be doing mistake. See, if you write this is due to Newton's third law, this is due to Newton's third law, then this is wrong. This is wrong. Totally wrong. Because if you see here, N and mg, they are of different nature. They are of different nature. They are not same. One is electromagnetic, another is gravitational force. And one more condition, if you see here, this condition is not satisfied. Two forces should be of same nature. In this case, two forces are of different nature. One is electromagnetic and another is gravitational, if you see here. And one more, see, two forces should be exerted on two different bodies, but here it is on the same body. See, here it is on the same body. So these conditions should be satisfied. These three conditions should be satisfied in order to apply Newton's third law. So most of the students, they will do like this. See, one more illustration I will give. Let us say this this table is not there. This block is falling down. This block of mass m is falling down. This is earth. This is earth. Let us say this is earth. Now block is falling down towards the center of the earth. Let us say towards the center of the earth. Block is falling down towards the center of the earth. It is falling down towards the center of the earth. Now in this case, how you can apply Newton's third law? See, mg is acting vertically downward. It is acting vertically downward towards the center of the earth. Towards the center of the earth. If this is the center, if this is the center of the earth, then mg, weight of this block, it is acting vertically downward. Weight is acting vertically downward. Now how you can apply Newton's third law here? See, this block here, it is exerting gravitational force upon earth, but earth, due to its heavier mass, it won't come up. Instead, this block, which is much more lighter compared to earth, this block will fall downward and it will, means it tends to go towards the center of the earth, this block, but earth won't come up. Two forces are same. See, with equal force, this mg, weight due to gravitational force exerted by earth on the block, this block is coming downward toward the center. Same equal force is exerted by this block on the earth, but this force is of same magnitude. Though it is of same magnitude, this earth won't come up because it is much more heavier. It is heavier. Here Newton's third law exists. See, because mg, both here gravitational force is exerted by block on the earth as well as by earth on the block, and both are gravitational force. See, if you see, both are of same nature, and also two forces exerted on two different bodies. So this criteria, an action reaction force exists at the same time. All three criteria is fulfilled. So all three criteria are fulfilled. So three criterias are fulfilled. Three criterias are satisfied. So you can say Newton third law is applicable here in this case. Newton third law is applicable. Third law is applicable or valid. Okay, so be careful. See, these two illustration is very important. Here student might feel, okay, block is coming down towards the center of the earth. Now how can we apply Newton third law? But block is also pulling this earth with same gravitational force, equal amount of gravitational force. That's why Newton third law exists here. The force is acting between two different bodies and forces are of same nature. But here in this case, see, n equal to mg, if you write due to Newton third law, you are wrong, because normal is electromagnetic force and mg is gravitational nature. So gravitational force, you can say this weight is due to gravitational force. So this is of gravitational nature and this is of electromagnetic nature. So nature of force should be same. It should takes place between two, it should exert between two different bodies. It should exist, or one body should exert force and another should exert same amount of force, same nature of force to previous body. So but here the case is only one object is there, so you cannot apply Newton third law here. So this is the conception that regarding Newton third law that I have clarified in this class. If you want more illustration, more example, more numerical problem for JE, NEET, IOE, IOM, for board level, for bridge course 11, 12, whatever means topic, whatever physics topic you want to discuss or you want to understand, you can comment in the comment section, and you please go through the video in detail, don't skip. You can see one thing I like to tell, see, while writing and simultaneously when speaker speaks, it may take some time. So what you can do is you can watch this video in higher speed, means there will be option in YouTube that is 1.5 times you can do speed, and then you can watch. Okay, if you have any doubt regarding this Newton third law, you can ask me. Yeah, whatever, see, this Newton third law, it is very important, and most of the student throughout the, see, I have taught in Nepal as well as in India, most of the student they fail to understand this Newton third law with 100% clarity. So my dear student, you should know at least basic concept in physics. So if you have any further queries, you can ask me. Thank you.